Yeah, now it's recording. Okay. Hold on a second. So, good morning, everyone. Today I'm gonna explain about autism, and autism is a spectrum disorder, ASD, and its factors, which is basically the same but has a wide range of other psychological disorders. But for a real quick introduction, I shall explain about this. That says in recent decades, much neuroscience research has focused narrowly on the cerebellum's. Uh, hold on a second. What is this? Is kind of showing up here? Guys, would you please just mute your microphones. In recent decades, much neuroscience research has focused narrowly on the cerebrum's role in genetics in balance, posture, and motor control. Two facts have stood in the way of wider recognition: non-motor aspects, non-motor aspects, aspects of cerebellar function. First, the most prominent deficits in acute cerebellar injury in adults are of motor nature. Monitoring the short-term results of injury does not capture long-term consequences that can accumulate over time. The consequences of cerebral deficit are highly dependent on when the outcome is assessed. And second, cerebellar connectivity is highly differentiated, and focal injury typically leads to focal deficits. Cerebellar dysfunction may disrupt the maturation of distant neurocortical circuits. And at the last paragraph, some cerebellar regions project predominantly to sensory motor cortex, homologous connections project to cognitive and affective regions, and comprise a large fraction of the cerebellar connectivity. So, as a brief explanation, this autism may occur due to the genetical factors, environmental factors, and some have damages to the cerebellum, the cortex, and some part of the brain during the pregnancy of the mother. And it's more likely to happen in the neonates and the children up to 2 years old of the age. So, and it also getting worse by the time during the adulthood of the patient. And so, what is autism spectrum disorder? Autism is a developmental disorder characterized by the difficulties with social interaction and communication, and by restricted and repetitive behavior. Parents often notice signs during the first 3 years of the child's life. These signs often develop gradually, although some children with autism experience worsening in their communication and social skills after reaching developmental milestones at a normal pace. Autism is associated with a combination of genetic and environmental factors. Risk factors during pregnancy include certain infections such as rubella, toxin including valproic acid toxicity, alcohol, cocaine, pesticides, lead, and air pollution, fellow growth restriction, and autoimmune diseases. I guess in women, in pregnant women with a case of epilepsy or seizure, if they find any case of valproic acid poisoning, might be a risk of incidence or autism in the child, in the neonate. So controversies surround other proposed environmental causes. For example, the vaccine hypothesis, which has been disproven. Autism affects information processing in the brain and how nerve cells and the synapses connect and organize. How this occurs is now well understood. And the Diagnostic and Statistical Manual of the Mental Disorder, DSM-5, combines autism and less severe forms of the condition, including Asperger syndrome and pervasive developmental disorder, not otherwise specified, like briefly PDD-NOS, into the diagnosis of autism spectrum disorder. Autism-related gene. We explained that it is a genetical cause sometimes, as in like 80% of cases is due to the mutation of specific genes. So the gene co-expression identifies cerebellar and neocortical sites of disruption. ASD related to co-expression networks have been found during two distinct periods of development. First, during human gestational weeks, 10 to 24 weeks actually, and expression occurs in a broadly defined somatomotor frontal region, which is almost this frontal lobe of the brain, and the prenatal and postnatal cerebral cortex, which basically it's the primary somatosensory cortex in this area, this red area of the brain. So it's more likely to causes dysfunction in these two major areas of the brain. So second, in humans from neonatal to age 6, cellular network expression is strong. Uh, Autism has a strong genetic basis, although the genetics of autism are complex and it's unclear whether ASD is explained more by rare mutations with major effects or by a rare multi-gene interaction of the common genetic variants. So complexity arises due to interactions among multiple genes, the environment, and the epigenetic factors, which do not change DNA sequence but are heritable and influence gene expression. So many genes have been associated with autism through sequencing the genomes of affected individuals and their parents. So studies of twins suggest that heritability is 0.7 for autism and as high as 0.9 for ASD. So the twins are more likely to show the risk of the autism. And siblings of those with autism are about 25 times more likely to be autistic than the general population. So the large number of autistic individuals with unaffected family members may result from spontaneous structural variations such as deletions, duplications, and inversions in genetic material during meiosis, which I showed in this figure. Like this is a deletion, this is duplication, and this is inversion. So it's basically has many factors, many different factors, which I explained: the environmental and prenatal factors like viral infection, prenatal age, gene deficiency, epigenetic factors like DNA methylation, histone modification, microRNAs, and genetic factors like copy number variation, point mutation, translocation. And you're wondering what are these brief words? These are just specific coded gene sequences for the that target the chromosome during the autism disorder. But some other factors of this, some cases that due to the viral infection might be abnormal fetal development, germ cell mutation, fetus brain development dysfunctions. So, and it leads to all the way to the ASD symptoms like sensory disorder, motor coordination disorder, anxious behavior, social deficit, repetitive behavior, lack of attention and activity. Which furthermore I explain about that. Prenatal risks for autism highlight a role for the cerebellum. So prenatal, there is prenatal. I explained there are two risks, like prenatal risk and postnatal risk. So what are the basic prenatal risks? Like prenatal age is important. We have shown that maternal infection is directly related to the fetal pathological status since the baby is developed and nourished within the maternal body. Similarly, the age of pregnant women and paternity were suggested as one of the most possible contributors to increasing the risk of autism. So paternal ages above 55 had at least twice the risk to have a child with autism compared with those below 50. Moreover, it is well known that the older the parents, the higher the chance of the miscarriage, fetal death, childhood cancers, and schizophrenia as well. So this is thought to be due to increase in de novo genetic mutation during germ cell development in the aging process. Another important factors for prenatal risk is zinc deficiency. The physiological function of zinc was first identified in the study of carbonic anhydrase. Currently, more than 300 zinc-related enzymes have been discovered, including isoenzymes. Zinc, as a cofactor in metalloenzymes, plays a catalytic role mostly in the transformation of substrates by aiding the formation of hydroxide ions at the neutral pH or through Lewis acid catalysis. Zinc is now known to be an essential trace element that plays a role in the immune system, protein synthesis, and wound healing. Moreover, zinc has been known to play a role in forming the zinc finger motif of proteins and binding them to DNA. So it's actually important for DNA synthesis as well. So the lack of zinc causes the DNA mutation sometimes. So suggesting that zinc is also involved in the resulting regulating gene expression here. Zinc also supports the fetal growth and development during pregnancy and development of children. Therefore, prolonged deficiency of zinc during pregnancy might lead to diverse dysfunction of embryonic growth, especially in neurodevelopment. A recent study also suggests that a toxic metal uptake and deficiency of essential elements increase the risk of ASD. So infectious processes. Prenatal viral infection has been called the principal non-genetic cause of autism. Prenatal exposure to the rubella or cytomegalovirus activities, the mother's immune response, and may greatly increase the risk for autism in mice. So congenital rubella syndrome is the most convincing environmental cause of autism. Infection-associated immunological events in early pregnancy may affect neural development more than infections in the late pregnancy, not only for autism, but also for psychiatric disorders of presumed neurodevelopmental origin, notably schizophrenia. So other maternal conditions, thyroid problems that lead to thyroxine deficiency in the mother in weeks of 8 to 12 of pregnancy have been postulated to produce changes in the fate of brain leading to autism. Thyroxine deficiency can be caused by the inadequate iodine in the diet and by environmental agents that interfere with iodine uptake or act against thyroid hormones. Possible environmental agents include flavonoids in food, tobacco smoke, and most herbicides. This hypothesis has not been tested, but included in here. So postnatal risks. Paracetamol, acetaminophen is actually considered safe to use during pregnancy, but somehow due to the gestational exposure, which is about, I guess, 46 to 68%, causing the inflammatory and immunological mechanism. So basically, it could be one of the risk factors for autism during pregnancy. Dollar neurons. This theory hypothesis that an early developmental failure involving in the amygdala cascades on development of the cortical areas that mediate social perception in the visual domain. The fusiform face area of the ventral stream is implicated. The idea is that it is involved in social knowledge and social cognition, and that the deficits in this network are instrumental in causing autism. And other factors for postnatal risk are autoimmune diseases, lack of vitamin D, lead poisoning, mercury, oxidative stress, and viral infection. There are two major periods of ASD gene co-expression. Epidemiological and clinical literature reveal two major time windows for environmental risk. These time windows, identified independently from the gene expression analysis, suggest a postnatal period when the cerebellum might influence ASD log outcomes. So a large body of research has investigated the hypothesis that the developing brain may be particularly vulnerable to the maternal stress and other environmental insults before, at, and after birth. So all of these autism risks are larger than the risks associated with advanced maternal or paternal age and suggest period of stress sensitivity that starts before birth. Plus, early disruption of the cerebral circuitry has been shown to be positively correlated with autism. Damage to the cerebellum at birth increases the risk, and Vineland autism screening inventories with the risk ratio as high as 40. So it's like 40%. These studies suggest that the cerebral insult is a very strong risk factor for ASD, and this idea is consistent with the fact that the cerebellum is among the most frequently disrupted brain regions in autistic patients. And as mentioned above, a second time window of vulnerability to ASD occurs in the postnatal years and suggests a role for experience. Autism becomes apparent during early childhood. So these are the specific regions of the brain which are affected by the autism. So as you can see, in medical terms, upstream and we have two terms like upstream and downstream. So upstream influences and downstream targets in autism spectrum disorder is the categorization of region showing abnormalities in ASD brain according to whether they result in lasting ASD like social deficits when injured neonatally, like neonatally when this disorder affecting the individual during the before pregnant and before they giving the birth, like upstream is called as term upstream, And when this ASD-like social deficit injured in adulthood is called downstream, or can be fully or partially compensated after an injury, regardless of age. So for major symptoms are basically psychiatric symptoms like social development. People with autism have social impairments and often lack of intuition about others that many people take for granted. Unusual social development becomes apparent early in childhood. Autistic infants show less attention to social stimuli, smile and look at others less often, and respond less to their own name. Autistic toddlers differ more strikingly from social norms. For example, they have less eye contact and turn taking, and do not have the ability to use simple movements to express themselves, such as pointing at things. Children with high functioning autism have more intense and frequent loneliness compared to non autistic peers, despite the common belief that children with autism prefer to be alone. Making and maintaining friendships often proves to be difficult for those with autism. Well, for them, the quality of friendships, not the number of friends, predicts how lonely they feel, and function of friendships, such as those resulting in the invitation to parties, may affect the quality of life more deeply. Communication. About a third to a half of individuals with autism do not develop enough natural speech to meet their daily communication needs. Differences in communication may be present from the first year of life and may include delayed onset of babbling, unusual gesture, and diminished responsiveness, and vocal patterns that are not synchronized with the caregiver. And the second and third years children with autism have less frequent and less diverse babbling and often integrated with words. So children with autism are less likely to make requests or share experiences, and are more likely to simply repeat others' words or reverse pronouns. Joint attention seems to be necessary for functional speech, and deficits in joint attention seem to distinguish in infants with ASD. Repetitive behavior is another major symptom. Autistic individuals can display many forms of repetitive or restricted behavior, which the repetitive behavior scale raised, with briefly called RBSR, categorizes as follows. So stereotype behaviors is one of the most important repetitive movements, such as hand flapping, head rolling, or body rocking. Compulsive behaviors, time-consuming behaviors intended to reduce anxiety that an individual feels compelled to perform repeatedly or according to rigid rules, such as placing objects in a specific order, checking things, or hand washing. Sameness, resistance to change. For example, insisting that the furniture not be moved or refusing to be interrupted. Ritualistic behavior, unvarying pattern of daily activities, such as an unchanging menu or a dressing ritual. This is closely associated with sameness, and an independent validation has suggested combining the two factors. Restricted interests, interest or fixation that are abnormal in them, or intensity of focus, such as preoccupation with a single television program or toy. Self-injury behaviors such as eye poking, skin picking, hand biting, and head banging. An estimated 0.5% to 10% of individuals with ASD show unusual abilities, ranging from splinter skills such as the memorization of trivia to the extraordinarily rare talents of prodigious autistic savants. Many individuals with ASD show superior skills in perception and attention relative to the general population. Classification. Actually, the autism is one of the five pervasive developmental disorders, or briefly PDD. Among of these five PDD forms, Asperger syndrome is closest to the autism in signs and likely causes. So Rett syndrome and childhood disintegrative disorder shares several signs with autism, but may have unrelated causes. Another form of the PDD is PDD not otherwise specified, or PDD-NOS, also called typical autism, is diagnosed when the criteria are not met for a more specific disorder. Unlike with autism, people with Asperger syndrome have no substantial delay in language development. Autism can also be divided into syndromal and non-syndromal autism. The syndromal autism is associated with severe or profound intellectual disability or a cognitive syndrome with physical symptoms such as tuberous sclerosis or TB. Although individuals with Asperger's syndrome tend to perform better cognitively than those with autism. The extent of the overlap between Asperger's syndrome, HFA, and non-syndromal autism is unclear. Multisensory defects in ASD suggest cerebellar dysfunction. So, the typical sensory responsiveness in ASD children can be detected as early as 4 to 6 months of age. Autistic individuals show abnormalities in eye blink conditioning, and most mouse models of ASD also show disrupted eye blink conditioning, including fragile eggs. Thus, multisensory learning deficits appear to be recurring features of both human ASD and animal models of ASD. Also, disruptions to the structure of frontal neocortex have been reported in ASD. 2-year-old autistic children attended more strongly to multisensory simple synchrony than more complex combination associated with natural biological motion. ASD patients show unreliable evoked neocortical responses to simple and non-social sensory stimuli. These abnormalities are potentially causative since sensory responsiveness and social symptoms are strongly correlated in high-functioning autism patients. Consistent with the cerebellar dysfunction hypothesis, motor dysfunctions are large with effect size of 1.2 and occur at the rate of approximately 80% in ASD. Finally, cerebellar learning deficits could affect not only sensory information arriving in the cerebellar cortex, but could also disrupt the processing of non-sensory information. The cerebellar mossy fiber pathway has a considerable corticopontine component, which conveys afferent copy for motor and perhaps non-motor information. Genetic epidemiology. Because autism is a neurodevelopmental disorder, the genetic aspects of autism has continuously been studied along with other factors that affect neurodevelopment. Therefore, studies have been conducted to find genes involved in each symptom of ASD and to identify how the genes are related to ASD pathogenesis. Chromosome loci that affect ASD is basically explained that the phenotype of ASD is very vague, and the specific factors that cause the disease have not yet been clearly elucidated. The diverse phenotypes of ASD may be due to the large number of genes or environmental factors involved in autism, resulting in different genetic variation that occur in each individual. Moreover, the diverse interaction between the various ASD-associated genes makes it difficult to interpret its pathogenism. So genes that have long been mentioned as involved in the causation of autism are FOXP2, RAY1ST7, IMMP2L, and RELN genes at chromosome 7. So basically, the most targeted chromosomes in these patients are chromosome 7 and chromosome 15. As you can see, it's numbered here as 7 and Q22 to Q23, which this 7 is a chromosome, the number of chromosome, and these are the sequence of the same chromosome from sequence of like Q22 to sequence Q33. Candidate genes on chromosome 7. Some researchers have focused on the locus of chromosome 7, as many genes in this region seem to be related to autism. And as you can see in this figure, I'll explain later. So an international study conducted by the International Molecular Genetic Study of Autism Consortium on 99 multiplex families was able to point out that the most probable ASD-related regions on 6 different chromosomes, chromosome 4, 7, 10, 16, 19, and 22, and some have 15, with chromosome 7 being the most significant. So as you can see, this is a chromosome 7. This is a sequence from Q11 all the way to Q36. Each of the sequence can get mutated by the risk factors I explained previous slides, and each one of them has a function. So for example, RELN on the 7q or the code is Q22.1, which is here. Yes. So briefly, gene called RELN. During development regulation of corticogenesis and neuronal cell positioning. Adult brain neurogenesis. Another Q31.1 is known to be related to neuropsychiatric disorders accompanied by multiple involuntary motor and phonic tics. Another also genes with a specific function. So yeah, severity levels for ASD. So like every other psychological disorders, ASD has 3 levels of severity. At level 1, so patient needs requiring support. Without supports in place, deficits in social communication cause noticeable impairments, difficulty initiating social interaction, and 3 examples of the typical or unsuccessful responses to social overtures or of others, and may appear to have decreased interest in social interaction. For example, a person who's able to speak in full sentences and engages in communication, but whose to and fro conversation with others fails, and whose attempts to make friends are odd and typically unsuccessful. So inflexibility of behavior cause significant interference with the functioning in one or more contexts. Another level 2 requiring substantial support. So marked deficits in verbal and nonverbal social communication skills, social impairments occurring even with the support in place. Limited initiation of social interaction and reduced or abnormal responses to social overtures from others. Example, a person who speaks in simple, like the same example, but in more even worse. So yeah, and like inflexibility of behavior, difficulty coping with change, or other restricted repetitive behaviors appear frequently enough to be obvious to the casual observer and interfere with the function in a variety of contexts. And level 3, which is the last level, more severe level of this disorder, is requiring very substantial support. So severe deficits in verbal and nonverbal social communication skills cause severe impairments functioning, very limited initiation of social interaction, and a minimal response to social overtures from others. For example, a person with a few words of intelligible speech rarely initiates interaction, and when he or she does, makes unusual approaches to meet needs only and responds to only very direct social approaches. Inflexibility of behavior, extreme difficulty coping with the change or other restricted repetitive behaviors. Now we're coming to the last parts, which is the management and medication. So for the non-formal pharmacological management, we have behavioral therapy, specialized therapy, and community support and parents training. So for behavioral therapy, we have sensory integration, applied behavior analyzer ABA, education of autism and related communication handicapped children. Specialized therapy, speech therapy, occupational therapy, and physical therapy. For medications, may be used to treat ASD symptoms that interfere with integrating a child into home or school when behavioral treatment fails. So they may also be used for associated health problems such as ADHD or anxiety. More than half of U.S. children diagnosed with ASD are prescribed psychoactive drugs or anticonvulsant, with the most common drug classes being antidepressants, stimulants, and antipsychotic. The typical antipsychotic drugs, risperidone and piprazole, are FDA approved for treating associated aggressive and self-injury behavior. However, their side effects must be weighed against their potential benefits, and people with autism may respond typically. So some of these drugs are risperidone, aripiprazole, fluoxetine, citalopram, methylphenidate, atomoxetine, clonidine, haloperidol, olanzapine, levetiracetam, and other drugs as well. So indication, risperidone is for aggression, stereotype, repetitive behavior, aripiprazole, aggression, stereotype behavior, with a specific dose of 0.25 mg, increased by 0.25 mg every 2 weeks up to 20 in pre-divided doses. Side effects might be LFT and metabolic extrapyramidal. Also the same for fluoxetine, also mood, anxiety, repetitive behavior, 5 mg AM OD increase up to 20 mg for some severe cases, GI symptoms, headaches, worsening agitation. Citalopram, also mood, anxiety, repetitive behavior, 2.5 mg AM OD increase up to 10 mg. GI symptoms, headaches, worsening agitation. And clonidine, overactivity, agitation, like increase every 1 to 2 weeks up to 25 movement. Okay, so someone, yeah. Okay. So haloperidol, 0.25 to 5 mg for a patient over the age of 2 years old. 2 years old, multiple problem behavior. Olanzapine, 1.25 to 7.5 mg, and these drugs are more likely to be used for children over the age of 2 years old to 5 years old, or the last two drugs are used also for adolescents for repetitive behavior, irritability, overall functioning, social behavior, sedation, and all those symptoms of the ASD. Yep. So thank you. Any question? Hello.
Okay, so that was a good presentation for that.
Thank you, sir.
About this one. And anybody would like to add anything? Any question anybody have?
Any question?
I had one doubt actually.
Okay, so
is there any use of oxygen therapy in these patients? Because improving oxygen perfusion can help in
oxygen therapy, you mean?
Yeah, oxygen therapy.
No, as a non-pharmacological management or some other management, if they just mentioned about like psychological therapy, like behavioral or specialist of or a psychiatric doctor, but they didn't mention like oxygen therapy. But I've seen for some severe cases of psychological disorder, they prescribing electric shock for like directly to the brain of the patient, not oxygen therapy. You know, I've seen that sometimes. So electrocuting the patient sometimes. Yeah.
Okay. Anything else?
Okay, so shall I stop recording?
Yeah.
Oh.
No,
Can
Stop recording.